Okay, you know what to do. Pause and copy, pause and copy. So our rider is sitting right there. Here's the support arm on my Ferris wheel, and I see a triangle immediately. Okay, side lengths, let's call this a y, let's call this an x. And this is my 10, and this is also a 10. Now, let's look at the question here. 10 meters is the radius. The 2 is revolutions per minute. Okay, so that makes revolutions per minute. That smells like angle. I want to think about angles here. So I'll put this angle here, theta. I'll come back to that later. 16 is the height from top to bottom here. No, it's not. No, it's not. The 16 is the height of the rider at this given moment in time. So what can I say there? Well, I can say that y plus 10 is 16. I'm looking for, what am I looking for? How fast is the rider rising? So the big question here is y prime equals what? Okay, so I need to find some equations that involve y. This one's no good, right? It's not, I need something, a function that involves y. When you can think about just finding y prime here, you'd get y prime is 0 if you did a derivative of both sides. That's obviously not what we're supposed to do. Okay, this equation represents a snapshot in time and not the general situation. We want an equation that represents the general situation. And what are we going to do? Well, as I said, the revolutions per minute makes me think about an angle. So I want to get an equation that involves an angle. Okay, that's what I meant when I wrote this right here. Okay, Pythagoras does not involve an angle, but the question involves an angle. So Pythagoras is not the first thing I write down. I will need it later, but for now, no good. So an angle formula about this triangle, well, I can write down, say, sine theta is y over 10, opposite over hypotenuse. Cos theta is x over 10. Tan theta is y over x. Now, which one of those do I like the best? It's going to be this one, because I'm looking for y prime, so that's no good. Cos theta does not involve a y. Tan theta, too many variables, right? Tan theta, it has the y, but it also has the x, so too many variables. I don't like that, so I'll use the sine theta. So sine theta is y over 10. And I'll take a derivative of both sides to get cos theta. And then chain rule gives me a theta prime popping out. And then on the right-hand side, I have y prime over 10. Now you'll remember, or maybe I should say, that this is also known as d theta over dt. We have this variable t that is hiding in the background. Now, what next? Oh, here we go. Here's my y prime. I can find it if I can find cos theta and theta prime. This 2, I think, is connected to theta prime. As for cos theta, I can go back to my triangle and try to sort that out. So let's do that. Cos theta from the triangle is x over 10. So if I can find x, then I can find cos theta. What's x? I don't know. How can I find it? Pythagoras. I'll write down Pythagoras. X squared plus y squared is 10 squared. I'm given, am I given y? I believe I am. Pretty much. Remember this guy? So y is equal to 6, right? So I'm given y is equal to 6. Plug that in, and I will have my x. So x squared is going to be 64. So x will be 8. Okay, it's plus or minus 8, but I throw away the negative because we're talking physics here. So x is 8. And that gives me my cos theta. My cos theta is going to be 4 over 5. So far, so good. So again, I want y prime. I found cos theta. Now I got to find theta prime. Now, what is theta prime? Theta prime is going to need a new color. How about purple? Why not? Now we're told something about this angle. The rate at which it's changing, 2 minutes for every revolution. So the rate of change of this angle is one revolution over 2 minutes. Okay, so we're doing calculus. So angles are always in radians. So 2 pi. A revolution is 2 pi. 2 pi over 2 minutes, which is just pi. And you could write, radians per minute, if you like. So theta prime is just pi. Okay, now we are finally set to finish here. We found cos theta, 4 over 5. We found theta prime, which is pi. And that's y prime over 10. And y prime is what we're looking for. Multiply both sides by 10, giving me 8 pi is y prime. And the units here, meters per minute, if I'm not mistaken. Yeah, 8 pi meters per minute. Okay, that was not easy. I had to kind of throw away Pythagoras, well, temporarily. But you really got to look at what you're given, okay? I'm given something involving an angle, so I write down an angle equation. I take a derivative. I ask myself, what do I want? So I want this y prime. That means I have to find this stuff. And I had to do some trig to get cos theta. To find theta prime, I had to interpret the question, 1 revolution every 2 minutes, and I was able to find theta prime that way.